Today's topic. We know when two segments are congruent, they have the same length. Two angles would be congruent if they have the same angle measure. But now, when are two figures congruent? How do I make two figures congruent? So up on your page here, I have a quadrilateral I'm naming ABCD, and a second quadrilateral I'm naming WXYZ. And if you take a look at what I'm giving you, what do I know about those two quadrilaterals? They are congruent to each other. So what's that mean now? What's that mean to us? All right, you're telling me these two figures are congruent. What's that mean? Here's what it means. In your mind right now, I need you to visually take quadrilateral ABCD, put it right on top of WXYZ for me. Okay, put it right on top. And what I want you to tell me first is, give me a pair of sides that would match up. You can leave it there. Thank you. Give me a pair of sides that would match up. Okay, can everyone do that visually? Put one right on top of the other. Give me two sides that would match up right now. Here we go. Start us off right. Zoe, give me a pair of sides. AB, line segment AB would pair up with WZ. I agree. Okay. Now, because the quadrilaterals are congruent, so are those two sides Zoe just gave me that match up. Since the polygons, the quadrilaterals are congruent, so are those sides that match up. And I'm already tired of saying the word match up. I'm now going to say they correspond to each other. Okay, those are corresponding sides. They match up. Okay, those aren't the only two. Give me more. Feed me. Here we go. 12. Olivia, another pair. DA. And what'd you say? DAN? YZ? Yep. Because the quadrilaterals are congruent and they correspond, they are congruent as well. Okay, third pair, please. Third pair. 1, 6. Ziv. Yep. And how about the fourth pair? 1, 5. Gabby.
CB and X.
Good. Yep. So if two figures are congruent, so are the corresponding sides and the corresponding angles. So now match up the angles for me and tell me which ones correspond. Give me a pair of corresponding angles here. Gabby, back to you. Angle. And you can use a single letter.
A.
And?
Z.
Got it. Good job. So that means A is congruent to Z because the quadrilaterals were congruent. Okay, more angles that correspond. 6. Oh, look at that, right on time. Gianna?
Angle B and angle W.
Yep. Good work. And give me a third pair that correspond and would be congruent as well. You owe me over there. You owe me. Charlie? I need another pair of angles.
D and angle Y.
Yep. And I won't ask anybody about the fourth because that's just process of elimination here, huh? C congruent to X. The polygons are congruent, so are their corresponding parts. Okay, when I say parts, I mean sides and angles included. I have a secret though. All right, I'd like to share with you. As everybody was telling me the sides and angles, I never looked at the diagram to see if you were correct, but I knew you were. And it's not because I've memorized this already. I never looked at the diagram to see if you were correct, but I knew you were. What did I use instead? That statement. Here's how I used it to see if you were correct. Who gave me the first one here? Was that you, Zoe? How did I know Zoe was correct? Ready? AB. Look in the statement. Everyone see where AB is, the first two letters? WZ. Look at that. Where is it? First two letters. All right. Look over here. Who gave me angle A and angle Z first? Okay. How did I know Gabby was correct? Where's angle A? First letter. What's the first letter over here? Angle Z. That's how these statements are written. When you tell me two figures are congruent, The order of the letters matter. That's telling you what sides and angles are going to match up. And in about 10 minutes, you're going to write one of these on your own. And when you write the statement that says this figure is congruent to this one, you have to make sure all the corresponding sides and angles match up. Okay? And this right here, just so we're talking in the same language, this is called a congruent statement. Okay, a congruent statement. This figure is congruent to this one with the sides and angles already matching up. So you don't need a diagram anymore. I just need the statement. Then I can tell you what angles and sides are congruent. All right, sound good? All right, this one I told you the figures were congruent. Next one, we're going to show me they're congruent. Okay, you're going to show me they're congruent. Whoa, before, please, wait, before we start marking, I know that's what I've taught you. Before we start marking, we're going to decide if these triangles are congruent or not. First, let's talk. How are we going to know if they're congruent? How many angles are in a triangle? How many angles? So that means all three angles in this one have to be congruent to all three angles in the other one. And how many sides? 3 sides. All 3 sides here have to be congruent to a pair over here. Okay, so we need a lot of information to figure out, do you see what we need before we say the triangles are congruent? All 3 pairs of sides and all 3 pairs of angles. We need them all. Okay? All right, so let's mark our diagram. Let's see what we got. Because I think I gave you a ton already. B and D are right angles. All right, we know how to mark those. A, B, and ED, so we can put a little hashers on those. It's been a while since we did this. Ooh, doubles, huh? Doubles on BC and CD. And then, ooh, triples on AC and CE. All right, let's try to get these triangles congruent, meaning all their sides and angles will be congruent. Well, I did half the work for you already. What do you know about all 3 pairs of sides? They're all congruent. All right, so now we only have to worry about the what, though? The angles. We got to worry about get all 3 pairs of angles congruent. Well, let's start here. What do we know about B and D? They're right angles, and then what do we know about right angles? They're all congruent. So step 2 should be, right? Oh, if B and D are right angles, that means B is congruent to D. And this is a reason we used in Unit 2 that never goes away, which would be all right angles congruent. Okay, the sides are taken care of. I have 1 pair of angles. I need 2 more pair. I will take care of one of them, but I'm expecting you to tell me the second pair. Look on your diagram here. This is something we have talked about already this year. There should be another pair you are confident in saying are congruent to each other because of this reason. Come on, we gotta start getting in the habit of boom, seeing these right way. You think you got it, Josh? Name them first. Don't tell me what they are. Name them.
Angle ECD and angle BCA.
Correct. Somebody else. How does Josh know they're congruent? What are those, Ian? Vertical angles. All right, we gotta see them. Gotta see them. Angle BCA congruent to angle ECD. Vertical angles are congruent. All right, so that means we only have 1 more pair left, which are what? We still need to show A congruent to E, and I'll take over now. Well, first thing, a lot of kids think they have this, and they go, L, A and E are congruent because they're alternate interior. They are, but what don't I have? Thank you. All right, I'm teaching you something there. I don't have parallel lines, so I can't say that. So there's got to be some other reason you're going to steal my fire. You better be right.
Because like the right angles can't like you say like oh they're parallel because like the right angles like since like they're both 90 degrees off of BD. Like,
So you're saying that those right angles are also alternate interior, and because they're congruent, they make the lines parallel.
Yeah.
Okay, you got me there. You could do that. Not what I was going to do, but that's fine. That's fine. I'm okay you saying that. See what Josh is saying? He says, okay, well, the lines aren't parallel now, but they actually are because I have congruent alternate interior angles. Okay, so I could do it that way. I'm going to show something different, though. Look at it. It's just like, you see what you started?
Isn't that like, since the other two angles are congruent on
Ian.
both sides, and since triangles
Ian. Ah, yes, you are correct. Here's what he's saying. All right, here's what he's saying. Basically, this is what I have right now in both those triangles. How many degrees in this triangle? Buck 80. How many in that one? 180, right? I already got 90. I don't know. I'm just going to make this up. Let's say that's 20 and that's 20. What do you know about the last pair then? Right? What do I have left? How many degrees if we're doing the math? 70, right? All right, so what do you know about those remaining angles? They have to be congruent. So if I have in two triangles, if I have two pairs of angles that are congruent, the third pair have to be congruent because they have to add to what? Each triangle's got to add to 180. Makes sense? If I have two pair in both triangles, the third pair has to be equal. Good? All right, and I have a name for that. So I'm going to say angle A congruent to angle E. And this is down on your text box. Is that how you knew, Ian? You already cheated and looked down?
No, it's just
Okay, relax. All right, smart. All right, showing off. Third angles theorem. This is called the third angles theorem. And you have a spot down below. And you, by the way, you can thank me later that I only allow you to write third angles theorem instead of the actual theorem. All right, that you're about to write in that text box down below. And we're not done with the proof yet, by the way. We're not done. We haven't accomplished our mission here. Third angles theorem. Okay, here's what the third angles theorem says. In two triangles, if two pairs of angles are congruent, finish it, then the third pair are. Yep. I think we're okay writing third angles theorem instead of that all the time. Okay, whoa, I'm not ready yet. Are you guys okay with this theorem and how it works? Here is a huge mistake that always happens with this theorem. Third, what theorem? Third, one more time. Third, there is no such thing as the third side theorem. Okay, a lot of kids like to say, ha ha, I got it. Here, look, I have two triangles. I know these two and these two, so the third pair must be. No, that's not how this works. Get out of my house. Get out of here. Okay, that's not how this works. Okay, it's only angles it works for, not sides. All good? All right, we haven't finished the proof yet. Can we go check real quick? Do I have all three pairs of sides congruent? Yep. Now do I have all three pairs of angles congruent? Yes. So now I could say the triangles are congruent. But like we said about 10 minutes ago, when you write this statement, the sides and the angles have to match up. So somebody's going to start us off. Who's up here? Charlie, name one of the triangles any way you want. Triangle BCA. And thank you, Charlie, because you were the first out of 4 classes today that didn't go ABC. Thanks for being creative. All right, so if I go BCA, I can't name the second triangle any way I want. The sides and the angles need to match up. All right, so let's try this out. What did angle B correspond with? D. Angle C kind of corresponded to, and I don't want to say itself, but C, right? And then A corresponded with E. And now just make sure the sides, I just did that based on angles. Let's see, does BC and DC match up? Yep. Does CA and CE match up? Yep. So this is a good statement. And for today only, here's going to be our reason why those triangles are congruent. Tomorrow, I'm going to show you different ways. Definition of congruent polygons. And what that says is if all corresponding sides and angles are congruent, so are the polygons. Love these days. Anything you guys want to ask? Oh, I can hear you guys talking in your group. You want more, huh? You want more because you're hungry? I'm going to feed you. There you go. Maybe we haven't had lunch yet. I'm going to feed you. I know you're hungry for another proof. Let's do it. Now prove these two triangles congruent. Go ahead. I'll give you a second to mark her up. What do I have? CG and DG. CN, DN. Angle C congruent to angle D. I know you know at this point of the year, but I'm just asking, what's that symbol in between GN and CD? Perpendicular. So what are you putting on your diagram? Right angles. All right, so to get the triangles congruent, I need all the sides and angles. What do you guys want to start with? Sides or we're going to have to do both eventually. Anybody have a preference, sides or angles? Zeev, well, go ahead. You make the class decision. I'm sure everyone else is happy. You want to do sides? Okay. How many sides do you know are congruent already? 2. So that means I just need one more. Look at the diagram. What are those sides I still need? You're going to take this, Zeev, because you knew already? Is that why you picked sides? Isn't it the same side I need? I need GN in this triangle and GN in this triangle. And I don't know about you, but I had something up on the board way back in the day that said GN, it didn't say this, but GN and GN, what do I know about them? They got to be congruent to itself. They're congruent to themselves by something we called, yes, Zeev, go ahead, reflexive. So get in the habit there. Triangles have sides or even angles in common. Full angles or sides, we can do reflexive. All right, sides are done. You ready for the angles? How many angles did I give you were congruent? Watch your mouth here. How many angles did I give you were congruent? Just one, right? C and D. You might have it beautifully marked on your diagram, but it's not in your statements yet. So let's take care of the right angles first. Okay. Can I say they're congruent in step 3? No, yeah, you guys are starting to pick it up. What do I still need to tell you? It's a 2-step process. I still need to tell you they are right angles. Yep. I didn't do that. Hey, I didn't do that in the last proof because I gave it to you. So it wasn't needed. But here, it's a 2-step process. Angle, what do we got? GNC and angle GND are right angles. Reason? I know we used 2 of them in here, but I'll call on somebody. You guys are waiting for that, I know. Zoe? Yep, definition of perpendicular, and then I know others use perpendicular lines, form right angles. Okay, now you told me they're right angles. Now you can say they're congruent to each other. So angle GNC, congruent to angle GND. All right angles congruent. Two pairs of angles now. How do I get the last pair? How do I get CGN and DGN, those top 2, equal? Do not make up something. Don't say definition of bisector. I don't see that word there. You're making it up. See? Why? Third angles theorem, right? If you have 2, third's automatic. All right? Third is automatic if you already have 2. So angle CGN congruent to DGN. Third angles theorem. And now we have everything we need to say. And now sometimes you're welcome. You don't need to make up the statement because it's in your proof there, right? You can just copy the proof statement. And that's a wrong. No, we're right. Yeah, I was going to say that's a wrong. Never mind. definition of congruent polygons. And again, this reason will change tomorrow when I show you different ways to do it. Okay, we're good? All right, I think I've hit you up with enough proofs. Can we go to now a little algebra problem? Not any algebra problem, honors algebra problem. This is using the third angles theorem. Okay, this is using the third angle. So does everyone see I've already given you 2 pairs of angles congruent? Have I made those markings pretty clear on your diagram? So what's that mean about the third pair? Right, they have to be congruent. So we're going to come up with a system of equations to solve right now based on this third angles theorem. So give me 2 angles right now, 2 angles that correspond to each other that I can set equal. One's, go ahead, Will. Give me 2 angles that correspond so I can write them equal to each other.
Angle.
I have 3 pairs of angles that are equal up here, Will, right? I'm asking you to just tell me 2 angles that are congruent up here. So I can set them equal.
Like the 18 and then 5x minus.
Correct. So 5x minus y is equal to the 18. Everyone's good there. Now, I'm not going to write 148 equals 148. That's not going to help me. But I can write 3x plus y equal to, now I know I didn't fill this in, but I think you guys have enough knowledge to find that missing angle. I hope anyway. All right, so the 3x plus y will correspond with, what's the degree measure of that missing angle on the top triangle? Ooh, Matt?
14.
14, you're good. Everyone all right? 180 minus 148 minus 18. That's how Matt got the 14. All right, now look at that system. That's not bad. It could be a lot worse. It could be really bad. Why is this not bad at all? What's happening? Y's, see ya! Right, they're gone. How many x's am I left over with? 8 x's. And then you do have to combine the 18 and the 14 for a 32. So x equals 4. Got that. Can somebody tell me a plan to find y now? Right, I need to find y somehow. Anybody a plan to find y? A couple different ways. I'll listen to whatever you have for me. Your approach there, Charlie. How do you want to find y?
Put it, like, plug it into 5x minus y equals 18.
Oh, you're going to do that one, huh? Instead of the other one, you're going hardcore, huh?
So I already did it.
Okay, relax. So 5 times 4 minus y equals 18, and then we solve for y. Yep. Or again, you don't like that, you can plug it into this one. Okay, you're going to get the same result. And we end up with y equal to 2. Any issues? And then last example, I just want a little more practice on writing a congruent statement. I'm going to fight you guys on this, though. I don't think they're congruent. I think this is a trick question. I don't think they're congruent. Here's why I don't think they're congruent. And maybe you can help me understand better. Here's why I don't think they're congruent. I've learned today that to be congruent, you need all 3 sides, which I have. I'm not arguing that. And you need all 3 angles congruent. I only see 2 marked up there. I see D congruent to Z, and I see F congruent to P. I'm saying they're not, because I don't have all 3 angles. Anybody want to fight back? I'm saying they're not. You don't know H is congruent to R. It's not marked with arc marks. Good. We're starting to some people are starting to realize. Do I need them marked? Do I need to mark H and R with arc marks? No. You already know they're congruent. Finish it. Finish it. Why? Why do I always know they're congruent? Thank you. Thank you. Third angles theorem, right? So you don't need them marked. All right. You already know. Hey, I know they're equal. Third angles theorem. You don't need to mark them for it. So yes, those triangles are congruent. I was wrong. So now let's write a statement saying they're congruent. So somebody first, name one of the triangles in any order you'd like. Woo, Haley, here we go. Big moment. Sure. Triangle DFH is congruent to. All right, finish Haley's statement. If we go DFH, how am I naming that other triangle? Doyle, good talk. Haley, finish your own statement now.
CPR.
Let's see. I just write it down, then I check after. Let's see. D and Z. Yep. F and P. Yep. H and R. Okay, now I check sides. DF and ZP. Yep. How about FH and PR? That's a good statement. And just so we're clear, is this the only statement I could have written that was correct? No. If I called on somebody else other than Haley, this might look a little different. All right, so just realize this is not the only statement. It depends on how you start the first triangle. I know I'm really hitting you hard tonight with those 4 problems, so go ahead, let's get going.